All right, guys, this is a special right triangle. More specifically, there's two special types. There's a 30, 60, 90, and then there's a 45, 45, 90. We're going to investigate the 30, 60, 90 first, and then we'll move over to the 45, 45, 90. Okay, so here we have equilateral triangles, which you should know that the angles are going to be 60. We're going to start off from that to develop the 30, 60, 90 triangle. Because if this is an altitude, that's going to be 30. If you look at this leg right here, we'll call that the short leg because it's across from the 30-degree angle. And this right here is going to be half of 4. Okay, so I'm going to just redraw this triangle. That'll be 2, that'll be 4, this is 60 degrees, that's 30 degrees. We're going to use the diagram here to solve for this side over here and see if we see any sort of relationships. So 2 squared plus b squared equals 4 squared. Minus the 2 squared, b squared is equal to 16, 12. Last step, square root, square root. Now we're going to go ahead and simplify the 12, which takes us to 4 and 3, 2 and 2. So this side over here is actually 2 radical 3. So I'm going to highlight those, and I want you to look at that. This is what we call the long leg. This is the short leg, and this is the hypotenuse. So you notice that in the hypotenuse and the short leg, that right there, you can see the 2 is half of 4. So that's something to recognize. And then over here with the long leg has the same coefficient as the short leg. The short leg is 2, and the coefficient is 2 also. It's a radical 3. Let's investigate this next one over here. I'm going to change these values to 6. Because it's easier to work with an even number and see the pattern. So I'm going to drop an altitude down. This is 60 because it's a equilateral triangle. That makes that 30. This leg is going to be 3. And then that's 6. So again, drawing this special triangle, that's 3, that's 6, 60 degrees, 30 degrees. So the short leg again is still half of the hypotenuse. Let's go ahead and investigate the long leg, this one over here. 3 squared plus b squared equals 6 squared. Subtract 3 squared, b squared equals 36, 27. Square root, b equals, get the factor tree over here. 9 and 3, 3 and 3, under 9, so 3 radical 3. So 3 radical 3 is this long leg. So let's highlight those and look at that pattern. We already said the short leg still half of that. And then look at the long leg. Both of those, you'll notice those 2 right there. They both have radical 3s, and the coefficients match the short leg. So anytime you have a pattern like this, that's going to be consistent for all 30, 60, 90 triangles. That's what makes this one special. So if you look at this table here, it should be pretty easy to get. If the short leg is 1, the hypotenuse we already know should be double, so that's going to be 2. If the short leg is 2, that's going to be 4. All you do is double the short leg to get double the short leg to get the hypotenuse. So for any variable or any size L, you just do 2L. Then, like we said earlier, the long leg came out having radical 3 next to it, being multiplied, and it had the same coefficient of the short leg. So if the short leg is 1, well, the long leg is going to be 1 radical 3. Over here, the short leg was 2, so that's going to be 2 radical 3, and so on. So there's this pattern here, and that's again what makes this Now this is only if you have some nice simple whole numbers right there. Of course, it gets a little bit more challenging. Okay, but if it has simple whole numbers like that, it's pretty easy. Okay, so here's how the conjecture goes. In a 30, 60, 90 triangle, if the short leg has a length of x, we're going to just use the variable x because that's what we always use. And the long leg has a length of x radical 3. And the hypotenuse is going to have a length of 2x. Remember, double x. So just to associate to the picture, short leg again is always across from the 30. This will be x radical 3, and this one will be 2x. So if you want to put some formulas to use, you can, always do the hypotenuse is always going to be 2 times the short leg, which we call x. To figure out the long leg, you can always do whatever the short leg is times radical 3. Okay? The other one that you can also consider is the short leg. And let's say you're given the long leg. For this one here, you'll notice it has radical 3. You can take the short leg and divide by radical 3 if you know the long leg. Don't take that back. Put that backwards. Divide the long leg by radical 3 if you're given that to solve for the short leg. We're going to do some examples here to represent that. All right, so let's start out with an easy example. Okay, real easy example. Let's go with this first one. This leg right here is 5, which you got to recognize that this is the short leg. So the short leg is 5, as you know, the hypotenuse is just double it, and the long leg is whatever that whole number is times radical 3. Well, what if they don't give it to you so simple? Right? You still follow the same pattern. To get the hypotenuse, you still want to double that. So how do you double that? Well, you times it by 2, like I wrote on the formula. 2 times 2 radical 3. What is that? That's 4 radical 3. So that's your hypotenuse. Then to get this, we said you just take the short leg and times it by radical 3. And there we go. So radical 3 times radical 3, you know, is just 3. 2 times 3 is 6. Okay, so these first two are if you were given the short leg first. These next two, they gave us the hypotenuse. The first one's pretty easy. There's a whole number 8. It's easy to go to the short leg first, okay, because this is 30. So half of 8 is 4. Then to get to the long leg, go from the short leg to the long leg. You just multiply that by radical 3. Okay, so that's the easy one. Now let's go to a more challenging one. This one is 6 radical 10. Okay, well, pretty simple here. All you have to do is take half of that, just like we did over there. Okay, take half of that to get that. Well, half of 6 radical 10 is just 3 radical 10. Don't take half of 10 because this is not in the 1/2 is not irradiant. So you cannot multiply 1/2 times that. So don't do that. Just stick to kind of like my terms. Okay, so then to go from the short leg to the long leg, when we do that, we multiply it by radical 3. So you need to simplify that. That becomes a radical 30. And you don't get any pairs out of that, so that's safe. So the long leg is 3 radical 30. Okay, so this is not in the form of something radical 3, well, because the hypotenuse was not a very simple challenging one to work with. Okay, this one's easy though. This is in the form that we want. Okay, it is 7 radical 3. So the coefficient, since that's a radical 3, the coefficient we know is going to be your short leg. So the short leg is 7, double the 7, we get 14. Okay, that's the easy one. Well, it doesn't look like x radical 3 over here. It's supposed to look like that. So it doesn't. X radical 3 is equal to 9. Okay, so short leg times radical 3 is equal to the long leg. This is the short leg times radical 3. Okay, so how do you solve for that? X, you need to divide by radical 3 to get rid of that. Divide by radical 3. And that's what I was saying over here on this formula. Okay, if you're given a long leg, you divide by radical 3 to get the short leg. Okay. So that's going to be a little bit of a process. X equals 9 radical 3 times radical 3 over radical 3. You cannot have a radical in the denominator. So we have 9 radical 3 over 3. The 9 and the 3 simplify to just 3 radical 3. So the short leg is 3 radical 3. What do you do to the short leg to get the hypotenuse? You just double it times it by 2. And so 2 times 3 radical 3 is 6 radical 3. Okay, so hopefully those examples will help you on the assignment tomorrow. Okay, let's go to the second investigation. And this is the 45, 45, 90. Okay. We're going to start off with a square because that's going to get us to this special triangle. Meaning, if you draw a diagonal from this right angle to that right angle, you know these are all right angles because it's a square. That produces that to be 45 and that to be 45. So I'm going to just draw it separately. That's 2, that's 2, 45, 45. Well, what does the hypotenuse look like? Let's do the Pythagorean theorem to figure it out. 2 squared plus 2 squared equals c squared. 4 plus 4 is 8. Square root, simplify the 8. Circle the pair. So this is 2 radical 2. So let me highlight those like we did on the other one and see if there's a pattern. Obviously that's related because they're both the same. And then here's the hypotenuse. Notice the coefficient. The coefficient is 2. Okay, let's work this other one over here. Draw a diagonal. This is 45 and 45. This is a square. And so let's do 5 squared plus 5 squared and see what the hypotenuse comes out to be. That's 50. Square root, c equals 25 over 2, 5, 5. See, these are easy radicals to do. You can way more difficult ones to simplify. So the hypotenuse is 5 radical 2. So let's highlight those and look at the pattern there as well. 5, 5 radical 2. So what happened there? Radical 2 is something that they have in common. Okay? The legs are always combined. Okay? Another name for this is an isosceles right triangle because 2 sides are combined. Okay? So the pattern is, if they're nice simple whole numbers, if the length of the leg is 1, well, the hypotenuse is going to be 1 radical 2. Or you can just write radical 2. You don't have to have the leg on. If the leg is 2, then the hypotenuse is going to be 2 radical 2. 3 radical 2, and so on. Okay? So just, to have it for any value, if the length is L length long, it'll be L radical 2. Okay, so let's do some examples here with this rectangle. Let's go to conjecture first. Conjecture is, in an isosceles right triangle, if the legs have the length of x, let's use x again, then given the hypotenuse has a length of x radical 2. Okay, formula to use if you're solving for the hypotenuse and you're trying to find or you're trying to find the hypotenuse and you're given the leg, all you do is you take the leg and you multiply it by radical 2. Now let's say you're given the hypotenuse and you want to solve for the leg. So you take the hypotenuse and you divide by radical 2 if you're given the leg. Or to solve for the leg, sorry. If you're given the hypotenuse, just divide. And you can see that you just divide by radical 2 and you get the x by itself, which we have representing the leg. Okay, so let's do these examples. This one's easy, super easy. The last four radicals here. So nice and easy when you have a simple whole number. This one over here is also easy because it's in the form that we want. This coefficient we know is going to be the legs because that's the way the patterns came out over and over again. Okay. These over here, these next two, these are somewhat easy. You'll figure out a pattern after we do this first one. Or maybe even the second one. This is supposed to look like x radical 2. We're given the hypotenuse, and we need to solve for the leg. So we're going to divide by radical 2, just like I said over here. See the hypotenuse? Divide by radical 2. So what is 6 radical 2? What is 6 divided by radical 2? Well, we got to figure that out by multiplying by radical 2 over radical 2. 6 radical 2 over 2, that reduces to 3. So 3 radical 2. And this is always the same. When you notice about the 3, this coefficient here, and the hypotenuse, you realize that is just half. Well, that's the situation over here too. If you have a nice whole number like that, just take half of it and put it next to radical 2. Okay, so this is a whole number, the hypotenuse. All you have to do is divide it by 2 and times it by radical 2. Okay? So divide by 2 and times it by radical 2. The last two, a little bit more challenging. So here, they gave us 3 radical 6. Well, this is also the same. That's easy. Over here, what do you do to this leg to get the hypotenuse? You times it by radical 2. What's 3 times radical? What's 3 radical 6 times radical 2? 3 radical 12. The only difference is you can't leave it out of 12 because you can simplify it. So there's your pair. Take it out of that. Why not? So this hypotenuse is 6 radical 3. So see, there's really no radical 2 involved here, but that's because we started out with pretty crazy number of 3 radical 6. Okay, and then the last one, let's say the hypotenuse is 3 radical 6. Well, what did we just say earlier? We take the hypotenuse and we divide by radical 2. Okay? So, the good thing about this, which I don't think y'all picked up on last time, this is a radicand and this is a radicand. If you have them like that, you can simplify those two together. So, the way you can rewrite this is 3 radical. How many times does 2 go into 6? 3 times. So that can be reduced there. So this is 3 radical 3, and this is 3 radical 3. Okay, let's say you forget that to simplify those, you'll still get the same answer. Multiply by radical 2 over radical 2. So you get 3 radical 12, which you know you got to reduce, and then that's 2. The 12, if you do the factor tree, remember the 4 and the 3 come out, 2 and 2, circle the figure everyone. So that really is 3 times 2 times radical 3 all over 2. The 2's cancel out. So you still get 3 radical 3. So that is it.